Hello, and welcome to today's lesson on radiation. Today, we will understand the concept of radiation as a method of energy transfer, including both electromagnetic and mechanical radiation. Then we will explore real-life examples of electromagnetic and mechanical radiation to illustrate how energy is transferred through these processes. So far, we explored the concept of energy transfer, understanding that energy can move from one place to another or change from one form to another while always obeying the principle of conservation of energy. We examined electrical work and heating as methods of energy transfer. Building on this foundation, we can now delve into the concept of radiation as a method of energy transfer, further advancing our grasp of energy transfer mechanisms in physics. Radiation involves the transfer of energy through waves. These waves can be electromagnetic waves like sunlight or heat, as well as mechanical waves such as sound and shock waves. These waves carry energy from one location to another. Let's consider an example of electromagnetic radiation: sunlight. When you're standing outside on a warm day, the sun emits energy in the form of sunlight, which travels through the vacuum of space and eventually reaches the Earth. When the sunlight strikes you, you can feel its warmth on your skin. This sensation of warmth is the result of energy transfer from nuclear energy in the sun's core to thermal energy of your skin through radiation. In this case, the sun's nuclear reactions produce high-energy electromagnetic waves, which travel across space and increase your skin's thermal energy. You might be wondering what the difference is between this and heating, since both lead to an increase in thermal energy. However, when energy is transferred by heating, it typically requires direct contact between the objects involved. For example, when you hold a warm mug of hot chocolate, the heat from the mug transfers to your hands because they are in direct contact with each other. This contact-based transfer is a key feature of heating. In contrast, a remarkable aspect of electromagnetic radiation is that it doesn't require direct contact for the transfer of energy to occur. This is evident in our sunlight example. You can feel the sun's warmth even though the sun is millions of miles away. The electromagnetic light waves emitted by the sun can travel through empty space, reaching Earth and warming everything they encounter upon arrival. While we commonly associate radiation with electromagnetic waves like light waves, it's also vital to recognize mechanical radiation. Mechanical radiation involves energy transfer through mechanical waves such as sound waves. These waves are generated when a source of energy causes particles in the medium to vibrate, and these vibrations propagate through the medium, transferring energy from one location to another. A classic example of this is the vibrations you feel when standing near a speaker that's playing loud music. Here, the kinetic energy from the speaker's vibrating diaphragms is transmitted to the floor via these mechanical waves. The vibrations you feel are a direct result of the mechanical radiation transferring energy through the ground. Unlike electromagnetic radiation, such as light or radio waves, mechanical radiation requires a physical medium to propagate. Mechanical radiation cannot occur in a vacuum. In today's lesson, we explored the fascinating world of radiation as a method of energy transfer. We learned that radiation can occur through electromagnetic waves, like sunlight, which transfers energy without the need for direct contact. This allows energy to travel vast distances, as seen when sunlight reaches Earth. We also looked at mechanical radiation, where energy is transferred through vibrations in a medium, such as the vibrations felt near a loudspeaker. By understanding these concepts, we gain a deeper insight into how energy moves and affects the world around us, whether it's through the warmth of the sun or the vibrations of sound.